So far what we are doing, shall we go for the class 3-4? Yes, please. Yeah. Permutations and combinations. We were discussing 3 different angles, you remember? So first angle was arrangement. So actually we defined permutation as arrangement and combination as grouping. So with the help of logical explanation for arrangement, I took the stage arrangement. So I had 3 chief guests A, B and C. So I had the stage arrangement. And for grouping, you remember? I was writing A in a paper, crush it and put it in the basket or dustbin or whatever it is. So a basket. Okay. So this was the first case. Second, uh, we were introducing the formulae. So when we were talking about formulae, we were discussing about the factorial notation where the explanatory mark is the notation symbol we use. And we started defining what do you mean by n factorial, what do you mean by n minus 1 factorial, and I asked you to remember 0 factorial is 1, 2, 7 factorial is 50, 40. Okay, so I did it here. And the formula for permutation is NPR is equal to n factorial divided by n minus r factorial. Whenever we have this formula, you have to remember that you have to do n minus r first, then the factorial. Okay, then we are discussing NCR. Okay, NCR is yes. Actually, it can write it as NPR divided by R factorial, or you can write it as N factorial divided by R factorial into N minus R factorial. See, this one, which I am just encircling here, is nothing but NPR. Is it okay? Then, how can you represent this NCR? You can write it as this NCR as NCR, or you can write it as C in brackets N comma R. Likewise, for NPR, you can write it as N, P and R, or in brackets you can represent for N and R. And we are also introducing a small relationship between N and R. You remember? What's the relationship between? Relationship means N is a number, R is a number. What do you mean by relationship is greater than, less than, greater than or equal to, less than or equal to. These are the relationships. Okay. Father, son or daughter. This is a relationship in human beings. When we talk about N is a number and R is a number, we are going to talk about the relationship in terms of numbers. So we'll be having less than symbol or greater than symbol, less than or equal to or greater than or equal to. So either you will call separately, if you talk about N, you will say this is nature of N. If you talk separately about R, you call it as nature of R. If you want to define the relationship, which means comparison between the two, we'll call it as relationship. Okay. Yes, tell me, what symbol you use here? What is this N? Total number given. What is R? From that, I'm going to pick up whether R can be 0 or R can be 1 or R can be 2 or R can be the maximum N. So what symbol I use here? N is this side and R is this side. Greater than or equal to, which means R can be less than N or R can be equal to N. And hope you remember I was talking about this one, R is equal to 0. Okay. Yes, R can be equal to 0, but still I'm not going to discuss about that because I don't want to confuse you with the concept because that is one extra point where we can understand in the later period. Okay, so you just know R can be 0 also as of now. Okay. Yes, third case. Yeah. Through definition, we tried to understand what do you mean by permutation? Yes. NPR. So if you are okay with permutation, you are okay with combination because you are removing only the arrangement. Okay. Yes. What is NPR? N into N minus 1 into N minus 2. And that last, if this is R, then this will be the rth term. Okay. The last term is nothing but the rth term. This rth term will be N minus R plus 1. Okay. How you get this is N minus R minus 1. Okay. And if you remove the bracket, it becomes minus r and this becomes plus 1. So this is n minus r plus 1. Actually, you have to write this as the definition. Okay, this is the simplified form. So probably I can write n minus, because we had both the type in exams. Actually, this is the definition. If you simplify that for the next step, this will become n minus r plus 1. Is it okay? So this is the last term. So how many terms will be there? R number of terms. Okay. This I have not discussed. Probably I shall discuss now. Along with the examples we'll do. Okay. So I'm talking about this point. First, let me go for permutation, then I'll go for combination. Yes. 5p3. Don't go by the formula. Go by definition. Yes. What is the first number? 5. Reduce it, reduce it, reduce it. 4, 3. And be sure that last term is n minus r plus 1. Here in this case, n is 5 minus 3 plus 1. Okay. So, 3. So, this is the last term. Okay. Also, you can check 11p2. Yeah. First term 11. Last term it should be 11 minus 2 plus 1. So, obviously 10. So, at one point of time, if you're not sure that where I have to stop, there is a hint. If there is 3 here, then you will have totally 3 terms. If you have 2 here, you will have 2 terms. The logic is very simple. I give you totally 5 persons who has to be arranged in the stage, and I say only 3 arrive, which means you're going to fill only 3 places, which means you will have only 3 factors. The logic is simple. Okay. Likewise, 11 persons in total. I'm going to give only 2 chairs for arranging. So 1 chair and another chair. That's it. Okay. So this is with respect to NPR. Now, can you help me out with NCR? The same will do for NCR. Yes, 5C3. We'll go by formula first because we don't have proper definition for combination. From permutation only, if we go for combination. Okay, yes, tell me. Formula. You just tell me the formula. What is NCR? N factorial divided by R factorial into N minus R factorial. We just substitute here. Yeah. 5 factorial divided by 3 factorial into 5 minus 3 factorial. Yes. 5 factorial divided by 3 factorial into 2 factorial. This 5 factorial can be written as 5 into 4 into 3. I stop here. Why means because I have this NPR, which is this one alone. Okay. Into 2 factorial. And divided by 3 factorial into 2 factorial. Obviously, this can be cancelled. From NPR, I can write NCR as, I'll write the other way. NCR as NPR divided by R factorial. What is NPR in my problem? Yeah, this is my NPR, right? See what you have done here. 5 into 4 into 3. What is this? 3 R. So, if you are asked to find 5p3, you take only 3 factors. If you are asked to find 5c3, you take the first 3 factors divided by 3 factors, which is R factor. See, these are all different methods. You can use it in any way. If you're okay with logic, go with logic. Sometimes logic is more better instead of going and substituting with all the formulas. Instead, you have like 720 to 20 factorial. You're going to work out with all these. Actually, the problem may be simple. There are 720 persons. You're going to arrange 2 persons. What would be the answer? Only 2 factors is enough. You go for that's the answer. You need not work out the full problem. You need not take the full formula and substitute everything over there. It's totally waste of time. So, and try to understand logically, try to understand by definition. This is by definition. You can understand this definition only if you are strong with the logic. Okay. Yes, one more point here. Probably I'll make a note here. Yes, NCR is NPR divided by R factorial. Please tell me whether you can write NPR is equal to R factorial into NCR. Yeah, find it. Yes, you can please make a note of it. So, in case, okay, let me finish it off. In case NCR is given and R value is given, what you can do? How can you find NPR? You can take NCR into R factor. In case NPR is given and R factorial is R is given. So if you know R factorial is known, right? NPR is given and R is given. Obviously, you can find NCR using NPR divided by R factor. The other is also easy. Yes, pa, please, pa. So this point I did not discuss in the last class. I'm just discussing now only. So I request you to make a note of it. Yes, please. Online, continuing. Yes, fourth content. Yeah, we're discussing about permutation where repetition is there. Okay, you tried with your name. I asked you to make as an assignment. Okay, so I tried working with my alphabets YAMUNA. So I collapsed my name using double Y or triple A or something like that. Double M, double N. So I tried in all the ways. Hope you also damaged your name. Okay, hopefully yes. Okay, fine. So what's the concept behind this? Actually, when N and R are same, this we are talking with respect to arrangement only, permutation. So when N and R are same, NPR will be NPN itself, which in turn is N factorial itself, right? We got this as the answer. Remember, for example, 5P5. Yes, 5P5. Substitute in the formula. 5 factorial divided by 5 minus 5 factorial, which is 5 factorial divided by 0 factorial, which is 5 factorial. So when N and R are same, you can write this as N factorial or you can write this as R factorial, both the same. Okay, yes, now tell me. But when there is a repetition, okay, just leave off this one. When there is a repetition, I got two A's in my name. So this is n factorial divided by p factorial, q factorial, r factorial, or whatever it is. Else we shall represent this as n factorial divided by p1 factorial, p2 factorial, p3 factorial. In your textbook, it will be given as n factorial divided by n1 factorial, n2 factorial, n3 factorial. See, the way of representation is different. Instead of P, Q, and R, you can take it as P1, P2, P3. Or you can take it as N1, N2, and N3. And so on. So till here we completed. Okay. Shall I go for the next concept? Hope no doubt till here. Okay. Yes. Okay. So fifth concept with respect to circular case. Okay. Which you call as circular or ring permutation. Okay. So far, we were discussing the arrangements in a line. If nothing is mentioned, we are arranging in a line, either left to right or right to left. Left to right and right to left, logically it may be different, but final answer will be same because left to right is one arrangement, right to left is one arrangement. So logically it may look different, but final answer will be the same. Okay. And we were discussing with respect to this striped shirt. Remember? Okay, black and white striped shirt. Now we are going to discuss with respect to circular or ring permutation. For convenience sake, I am going to take four alphabets. Okay. So A, B, C, and D. See, generally, if I do it, in how many ways I can arrange it? Forgot about circular and ring. Normally, in how many ways I can arrange it? Number of arrangements can be done. Yeah. Number of arrangements that I can do with this A, B, C, and D. N is equal to what? Always fix your N, fix your R. And remember that R is less than or equal to N. Okay, yes. N is 4. R, I'm not giving any restrictions, so R is also 4. Yeah. So this is 4 factorial. In 24 different ways you can make it. So no doubt in this. Let me continue. For convenience sake, I'm going to take only two cases. Okay, one is A, B, C, D, the original arrangement itself, and another one is A, C, B, D. Obviously, this is a different arrangement. Okay. Now, for this one, let me arrange in circular manner. Circular means a table is there. Okay, please try to understand the concept. You're making them to sit in a round table. So there is a table where you are going to make sit in four different chairs facing each other or facing the podium or whatever it is. Okay. So for convenience sake, I name the position as position 1, position 2, position 3 and position 4 because we need to know, right? We need to understand. Yes, what happens in this case? First case. Yeah. What happens in this first case? Let me make A sit over here. Yes, tell me. A, B sit over here because I cannot change the position, right? Or C sit over here or D. Usually, if nothing is mentioned, we'll go clockwise. Okay. If you go anti-clockwise, it's different. Okay. Now tell me. Second. So this is one way. What I'm doing here is this. I named as position one. I'm making A to sit in position one. Shall I make A to sit in position two? Just make a try. Okay. So what happens? Yeah, tell me. So I'm going to make A to sit in position two. So A sit here, B sit here, C sit here, D sit here. Okay. Then let me go with another one option where A can sit in three. Third position. A sit here, B sit here, C sit here, D sit here. Is it okay? Let me try one more. Yeah. A to sit here now. Fourth position. So A sit here, B sit here, C sit here, D sit here. Okay. Did you find that all the four positions are different? See, because I have named this as 1, 2, 3, and 4, you think that A is sitting in position 1 and B is sitting in position 2. We are talking about arrangement. Whenever I make some changes here, the position where A and B together and A and D together is not changed here. You check. In this case, B is sitting next to A and D is sitting next to A. What happens in this case? B and D. See, the position for B and D is not changed. What about here? It's not changed. What about here? Not changed. Even when you try with this option, the same thing will happen. Shall we make a fast go through? Yeah. A sits here, then C, then B, then D. Now your mind focus should be who is sitting next to A. That is either next to means this side next or this side next. Because round table you cannot say left and right. Okay. Yes. Now tell me. If I change the position, see this position only we know. Okay. Yes. I can make sit here A, then C, then B, then D. What happens? No position is changed. Yes, next case. Where I'm making the person A to sit over here. Then C here, B here, D here. See, no position is changed. Okay. Now what happens? The last case. Yeah. A here, C here. A here, C here, P here, and D here. See, nothing is changed. So whatever you make, we say that I get four different options, Anna. No, I get only one, which means arrangement is repeated. So far from the prior knowledge, we know that if arrangements are repeated, what we'll do? We'll remove the arrangements, which means we remove the repeated arrangements. So actually, we have here n factorial ways of arranging. Okay, here, number of arrangements made is 1, 2, 3, 4. So you divide by 4, which is 4 factorial divided by 4, which is 4 into 3 factorial divided by 4. Strike out this 4, you get 3 factorial, which is nothing but n minus 1 factorial. Please try to understand. Let me repeat it. Here you will not divide by 4 factorial because I have completely worked out. I have worked out all the arrangements. So totally how many different arrangements we thought? 4, but it's not different. Okay, so I divide by 4, not 4 factorial. I divide by 4. So this is 4 factorial divided by 4. 4 factorial can be written as 4 into 3 factorial divided by 4, and 4 will get cancelled. So ultimately we get only 3 factorial ways of arranging, which is n minus 1 factorial. So in the case of circular or ring permutation, now your formula is not n factorial, but this is n minus 1 factorial. Yes, please make a note. Online continuing. So what's the formula for ring permutation? N minus 1 factorial. Sometimes in our material, instead of this explanatory mark, they use it as this way. Okay. So this like L shape. Like this L is like elongated L. So this also we use. Uh, There is a special case in circular or ring permutation. What we say here is, so far when we talk about circular or ring permutation, we talk about clockwise. See, when we talk about line arrangement, we talk as left to right and also right to left. The same way when we talk anti-clockwise. Obviously, clockwise is different and anti-clockwise is different, and the final answer will be same. Okay. But sometimes what happens is I have some arrangement like we get usually this problem will get necklace arrangement, bead arrangements. Probably I'll take two beads. One is red color bead and another one green color bead. I'm going to make a necklace design. So I make a design like this. Okay. So tell me, you don't see this as a design exactly. I go clockwise. Okay. You say red and black or black and red. First, black man. Sorry, not black. Sorry, green. Okay. Red and green, green and red. This one is right or this one is right? See, both are same one. If I start with green, you'll say green and red. If I start with red, you say, okay, see, I started, see, actually don't fix this side as in your mind. I started with green, so you say green. Don't do that. Okay, because I took a green color ink, I started with green bead. Okay, so red and green and red both are different. No, it's not different. Likewise, if you go for anti-clockwise, red and green, green and red, both are same. So whether you go for clockwise, whether you go for anti-clockwise, is both same only. Already when we talk about permutation, circular permutation, the formula is now not n factorial, but n minus 1 factorial, right? But because we don't have two arrangements, we have to divide this by 2. See, clockwise is one way of arranging, anti-clockwise is another way of arranging. So what I have to do? I have to remove the repeated arrangement, so I divide by 2. So what's the formula? N minus 1 factorial divided by 2. This is where clockwise and anti-clockwise distinction is not made. Distinction means difference is not made, which means the repetition is done. Okay. So either you can write in this way or usually we'll have this as a formula. We know this one, right? N minus 1 factorial value divided by 2. So half into n minus 1 in factorial. Yes, but you can please make a note of it. So the heading for this one will be clockwise and anti-clockwise, anti-clockwise, where no distinction is made. No distinction means same repetition, same arrangement. No distinction is made because we use the same term in the exam. That's why I don't want to make the term changed. So no distinction is made. Okay. Yes, please. Will I continue? Online continuing. Now we'll do some small analysis work. NPRS n factorial divided by n minus r factorial. NCRS, yeah, final formula. N factorial divided by r factorial into n minus r factorial. What we are going to do actually here is we'll go for different cases. We already know the relationship that r is less than or equal to n. Again, r can be 0, but I'm not going to discuss now. So let me go with r is equal to 1. Okay. R is equal to 2. Last value will be r is equal to n. Before that will be r is equal to n minus 1. Okay. And you can have any number of values. I'm not going to discuss all. I'm going to take only these 4 cases. What we are going to do here is we are going to find the value of all these NPRs. So probably n, keep it as n itself, because we are analyzing it. You're not finding the value. If I give the value of n, obviously you're going to end up with a final answer. I don't want that answer. I don't want to go for the final answer. Instead, we need to understand what is actually happening inside. So let n be n itself. So what happens in the first case? This will be NP1. This will be NP2. Likewise for NCR, it will be NC1. This is NC2. And here it will be NP n minus 1. And here it will be NPN. And here it will be, so you may have any number of values. Need not worry about that. Yes. Here will be NC n minus 1. And here will be NCN. Can you please make a try? So let me tell you what I'm going to do here is the answer what I get here for all these values, I'm going to compare it, and also I'm going to make a comparison with these values also. Like I'm going to compare NPR and NCR, and I'm going to make an internal comparison also. So this is my logic behind it. Yes, why don't you try, please? I will give the end result. You need not worry. You just find the answer. Okay. Again, if you ask me, ma'am, we have not given the value of n. No need. Try to simplify at the most. Okay. And keep it as it is. Yeah, please join. NP1. Yeah. N factorial divided by n minus 1 factorial. Where you can write n factorial as n into n minus 1 factorial divided by n minus 1 factorial. So ultimately these two terms will get cancelled, and your final answer is n. Okay. So next one, np2 n factorial divided by n minus 2 factorial. So I shall write this as n into n minus 1 into n minus 2 factorial divided by n minus 2 factorial. I shall cancel it. So my answer would be here n into n minus 1. In case, I am not given this, but in case, if r is equal to 3, obviously we can guess the answer for np3 is going to be n into n minus 1 into n minus 2, because this is by definition will get it, okay. But anyway, my focus is not for r is equal to 3, but I'm just generalizing here. Next, I'll go for r is equal to n first. Okay, yeah, r is equal to n. Already we have done with r is equal to n, that's why I took this one, yeah. N factorial divided by n minus r, which is n factorial. So n factorial divided by 0 factorial, which is n factorial divided by 1. So this is n factorial itself, right? Right? Now r is equal to n minus 1. Yeah. N factorial n minus, actually this is n minus n minus 1 factorial. Am I right? You have to write it this way. If I remove the inside brackets, this will become minus n and plus 1. Okay. And obviously this is going to be n factorial divided by 1 factorial, which is n factorial itself. Did you understand the beauty over here? What happens when r is equal to n minus 1 and r is n? Let me box the values. I'm discussing only these two cases. Okay. Which means both the number of arrangements in the two cases are same when r is equal to n minus 1 and r is equal to n. This is your first result. You can make a note of it now. So if you ask me how to have to make a note of this one, man, you write the heading as result. First one, np n minus 1 is equal to np n, right, is equal to n factorial. This is how you present it. Okay, npn minus 1 and npn is equal to n factorial, which means r value is different, but ultimate number of ways is npr. In this case and this case will be both n factorial. See, so far we were discussing only this case, right? In the earlier class and the beginning of the session, we were discussing only r is equal to n. It's n factorial. But now happens we have got an extended result. Okay, yes, Bob. So this is my first result. Shall I continue? Have you taken note of it? Yeah. So you're now becoming experts. Yes, right. Okay. And also this one we have done the first case, which I am making a box now. When r is equal to 1, the value is n itself. Yes. So this is result 2. NP1. Don't write it as NPR, then R is equal to 1. We want the final result. So NP1 is N itself. Okay, for remaining R and all, what we can do here is we can take the definition itself. So you need not overload. So when it is R is equal to 2 or R is equal to 3, R is equal to N minus 2 up to N minus 2. So probably you can take a note here and you can say that what? For R is equal to 2 to N minus 2, you apply, go by definition. Okay. So whenever you find this r is equal to n minus 1 or r is equal to n, your answer is going to be n factorial. When r is equal to 1, your answer is going to be n. Okay. So this is all we have done with permutation alone. Now I'll go for permutation. So this is internally we are comparing. We are comparing only the permutation part. Okay. Take a note of. Okay. Continuing. Yes. Join for NC1. NC1. N factorial. So you're going to substitute over here. But anyway, I'll get the value. What value I'll get here? NPR divided by R factorial only, right? Okay, anyway, we'll do it. Please tell me. NPR is N here, okay, divided by R factorial 1. See, you would do it by this way, I know. I'm doing by this way. Anyway, your answer should be this one. Okay, I'm trying to match the answer so that you'll get knowledge in both the ways. Okay, yes, you got the answer as N? Okay, fine. Before continuing, if you make a note of NP1 and NC1, you'll find both the answer is N. This is by formula we are applying. You just go by the logic side. Only one is there. What type of arrangement you will do it? There is nothing to talk about circular arrangement. There is nothing to talk about left to right or right to right, left to right arrangement. So there is only one element I'm talking about. There is no talking of grouping and there is no talking of arrangement. You just pick one and put it outside. So it becomes so simple. So this is your result here. So you can, I think the result here I added is second one. Shall I name this as third one? Yes, what we have done in this NP1 and NC1 will be both N itself. Okay, which means there is no arrangement. So what do you understand from this? No need to talk about arrangement or no need to talk about grouping, right? Yes, please make a note of it. Will I continue? Yes, kindly join. NC2. Already we know the answer as n into n minus 1 divided by 2 factorial. Let me have this one as it is. Okay. I don't want to do anything further. Probably in later period I'll take this value. Let me have n into n minus 1 divided by. Yes, NC n minus 1. Yes, what you get? Numerator is n factorial. Okay, n factorial divided by n minus 1 factorial. Yes, what I can do? N into n minus 1 factorial divided by n minus 1 factorial. So you got the answer n. Okay. Yes, now tell me the last one. NCN, which is n factorial from the permutation value divided by is equal to 1. No? Okay. So what you have to understand from this one is when you get n and you get okay, probably before continuing I have to introduce about r is equal to 0. Let me go talk about r is equal to 0, then I'll come back. Okay. So let me take a fresh page. R is equal to 0. What happens? What do you mean by r is equal to 0 first of all? When I give n and when I say r and when I talk about NPR, you have to pick r number of elements or r number of persons that you have to arrange. Or when I say NCR, you have to take r number of r number of persons and you have to group it. Okay. I give you different color balls. Black, red, blue I name it as B itself, green and yellow. So how many balls? 1, 2, 3, 4, 5 balls. N is equal to 5. I ask you to put 3 balls in the basket. So this is NCR. Okay. Now I say R is equal to 0. What do you mean by R is equal to 0? Okay. You go for the exam hall. Okay. You have this habit of seeing the instructions, reading the instructions. So it's mandated. You have to read the instructions before going for the usually for mathematics, we believe that memorizing the formula is a hardship, right? Okay, for me especially, before going for the exam hall, I have all the formulas and I'll start memorizing it. Even then, I'll make wrong only. That's different. You go inside the exam hall, instead of seeing all the question papers, you read the instructions and you turn the page, you have all the formula lists in your answer paper, in a question paper. How you feel? You feel like, I'm passing that. Right? The same thing is happening. Okay, what's the link, ma'am? I give 10 number of persons. I say, don't do anything. So what are you going to do? You're not going to, that's what R is equal to 0. Which means you're not going to arrange, you're not going to group. Okay, this is the logic. Yes, now tell me. When R is equal to 0, what is NPR? Which is NP0. Yeah, make it faster. Tell me. N factorial divided by N minus R factorial, which is N factorial divided by N factorial 1. Okay. R is equal to 0. Yeah, tell me. This is already 1 divided by 0 factorial, R factorial, which is 1 factor 1 divided by 1 divided by 1. Yeah, what happens? What do you understand from this both 1? You don't do anything, which means already there is an arrangement. Which means there is no arrangement. You don't do anything, already there is a grouping. Which means one grouping is there. So the answer is 1. So just now I introduced about R is equal to C. Okay, clear up? The question is given. You don't answer, you'll get marks. Okay, it's nice, right? So R is equal to 0 means you're not going to do any arrangement, you're not going to do any grouping, but default there will be an arrangement and default there will be a grouping which takes the value 1. Default means there is default 1 arrangement. There is default 1 grouping. So obviously the answer is going to be 1. Yes, you can click. Okay, now come back over here. Uh, so let me extend this point. What is NC0? Just tell me what is NC0. Actually, I have to work out MP0 also, but we already have done this one. So NP0 is one we know. What is NC0? One we know. Now, what happens here is already I have done a box with NC1. Now, I'll compare with this one. What's the value? N. I request you to have a note on R value. Okay. Likewise, let me box these two values. Please have a look on the board. This value and this value. Okay. Now have a look on this R value. Probably, if I want to zoom out those values, I'm talking about this N value. For two values of R, I'm getting N. Then this one, NC1, and this one, NC N minus 1. And also, I'm talking about this one. Okay. For two values, I'm getting 1. Yes, this is NC0 and this is NCN. Okay. Now, my focus is on this R value and this R value. If you add these two R values, you'll get N. See, add only the R value. Likewise, if you extend the next case where NC3, what is the earlier case for this one? NC N minus 2, right? The earlier to this one. If you add these two, what you'll get? You'll get, sorry, this is NC2, right? Sorry, this is NC2. Because I have taken NC1. Okay, this is NC2. Yeah, what value you'll get? You'll get N. If you add these two, you'll get N. What's the logic behind this is, I have 5 people. I name the people for convenience sake as A, B, C, D, and E. Okay. I want to pick only 2 people from here. Okay. Anybody can help me? Which 2 people I can take? Give an example. Don't give the different ways. I don't want to give an example. Just help me out. I'm going to form a group. I'm going to pick only 2 people. Yes. Name any people. I'm asking the example. Shall I pick C? And shall I pick A? Yes. Just I'm asking the example part. Okay, I'm asking the answer. I'm asking the example. Okay. Now have a keen look. When I talk about these 2 peoples forming a group, ultimately I'm not picking B, I'm not picking D, and I'm not picking E, which default form a group, right? Which means when I talk about these 2 persons, I automatically form a group where D, B, and E are formed as a separate group. So this is 2, this is 3. Ultimately, how many people together? 5. So this is the logic behind. See now, this is R. Okay. And this will be N minus R. Am I right? Or you can take this R. This is N minus R. Now see here. This is R. This is N minus R. Right? This is R. This is N minus 0, which is N minus R. This is R. This is N minus R. So ultimately, if I form grouping as NC2 and NCN minus 2, which means NCR and NCN minus R, the both will have the same value. So this is your next result. So what's my result number here? 4th. Okay, so this is my 4th result, which says NCR and NCR minus 1 will be equal. The values will be different, will be equal. But ultimately, from the above discussion, we have taken NC0 and NCN is equal to same. What's the value? 1. And NC1 and NCN minus 1 are same, where the value is N. Yes, please. So probably you're making note of these cases, right? It's clear on the board? Yeah. 5th one, we can add it as 5th one. When R is equal to 0, what's the value we get? Already I had done with it. NP0 and NC0 will be both same. What's the value? 1. When R is equal to 1, what you get it? I'm just listing it, okay? R is equal to 1, what you get it? What is NP1? N. Okay, what is NC1? N. Probably instead of writing, I can write as NC1 is equal to N itself. And yes, one more. When R is equal to N, NPN is N factorial and NCN is 1. Is it okay? So you can close with this. So one more small concept I have pending. So almost concepts are all done. Only one more concept. If you want to make a note of the fifth one, yes, please. Shall I take over? The main heading here is restricted permutation and restricted combination. Restricted cases, restricted permutation and restricted combination. Okay. This follows two cases. Case one, where we restrict in the sense that it should mandatorily occur. So we give the heading as must occur case. I'll give an example, okay. Second is must not occur case. Mandatorily you restrict saying that must not occur. For example, so with respect to permutation, what we were discussing is, this is for permutation. What we were discussing is the table arrangement. We say that there will be one person who is a very, very important person. This VVIP or this chief guest will be there. Other will be called as guest of honor or guest or something like that we call. But this one person will call as a chief guest. Okay. So you make the table arrangement where there's one table arrangement should be chief guest. Okay. So this is must occur. So for chief guest arrangement. Okay. Must not occur is you should not have extra chairs like. So which means probably we are talking about 5 persons and in this Mr. X should not occur. Okay. So this is should not occur case. Mr. X or Mr. A or whatever it is. Should not occur. Likewise happens in the same of combination also. In the case of combination, I'm going to pick 2 persons A and B and this A and B should be there. I'm going to form a committee. Okay. And I say that this committee should have Mr. A. This committee should have B and C compulsory. Likewise, must not occur case. X and A should not be present in the committee. Okay. Now let me go for the example. For convenience sake, let me take N is equal to 6. Okay. And R is equal to, I'll take 2. Okay. Or I'll take 4. I'll take, I'll slightly change the values. N is equal to 7 and R is equal to 5. Okay. This is must occur case. This N is equal to 7 is 7 different persons. A, B, C, D, E, F and G. Okay. I need to arrange the tables where only 5 persons will be arriving. And this chief guest, no, he has already arrived. So he must be there. So the chairs which you arrange. So in some programs you might have seen the judges, the chief guests will have a separate chair arrangement. So to differentiate. So in that way, this person A, I name this person as the important person, must occur case. So remaining four chairs, I don't know who it is, which means this five, I can split it as 4 and 1. Am I right? Now we are worried who are the other four persons. Now we have to arrange it. If there is no restriction, what would be answer? If there is no restriction, what would be answer? Ma'am, totally 7 persons, ma'am. I have to arrange 5, ma'am. So 75, simple. But now I'm restricting this one person is definitely there. So remaining, how you have to choose? Only 4. So shall I make this as instead of 7, I make it as 6 because already one is there. And instead of choosing 5, shall I make this as 4? Because already one is present. So in how many ways I can arrange it? 6p, 4. Is it okay? Now, instead of making this as 1, I'm extending the case. Please try to understand. Instead of making this as 1, I say that A and B both are important guests here. So we need to have separate chair arrangement for them. But anyway, only 5 people are going to sit in the stage. So now this becomes 2 and this becomes 3. Yeah, what happens now? Totally 7, but I'm going to have only 5 here because already 2 is compulsory there. And out of this 5, actually I have to choose 5. See, this R 5, but already 2 is there confirmed. I have to choose only 3. So from this 5, I choose 3. Okay, now what's the problem here is these two persons A and B, where they will sit. See, when I say it's 5p3, I'm talking about arrangements. Where I'm going to make these two persons sit. Is it okay? So this is how many seats you will be arranging here? 1, 2, 3, 4, 5. You can make this A and B sit over here or here or here or here or here. Now make this as another one new problem. How many are total here? How many seats are in total? 5. And you're going to make these two persons sit in these 5 places. So this becomes 5p2. This was your overall problem, and because of these two persons must occur, now you will have a small internal problem. This is what you call as internal arrangement, and you have to multiply this internal arrangement. You know what do you mean by multiplication? We are often repeating this one. Multiplication means under. Under means compulsory. So you have to multiply by 5. Is this clear till here? Let me finish it off. Now I have to give the formula for this. Yeah, what is N? 7. What is R? 5. You should not get confused with this 5 and other 5. Okay. I have kept this 5 as R itself in my problem. Sometimes the values may be repeating. You should not get confused with the values. So R is 5 here in my problem. And this particular two persons. Okay. For convenience sake, most of the books we have this value as P only. Now substitute here. What is 5? N minus P. Am I right? 7 minus 2. Why you took 5 here? Because I don't want to take 2 because they are already present. Okay. P. What is this 3? This 3. 5 minus 2. Am I right? So this is, yeah, R minus P. Yeah, thank you. Into, what is this 5? This R. See, this 5 is this 5. The 5 tables or the 5 chairs. Yeah. So this is R. P, what is this 2? This A and B are 2. So this is P. This is the formula. See, your formula seems to be very lengthy. If asked as a formula, obviously I have to write the formula only. If given us a problem, you can manage. If given us a problem, you can directly apply your logic. You need not apply the formula over there. You can apply the logic. If formula is directly asked in the question, you need to understand the formula. So the formula is simple. N minus P, P, R minus P into R, PP. This is for permutation. Let me finish off combination. Probably this one I'll discuss as second case. Let me finish off combination. What happens in the case of combination? Yeah, what happens in the case of combination? Instead of P, change it as C. So this is N minus P, C, R minus P. You will not get this term because this is for arrangement only. I have 5 chairs. I have to make A and B sit in these 2 chairs. Here I'm not going to talk about chairs and arrangement. So I'm talking about only picking the persons. So this is 5C, 5 minus P. Sorry, N minus P, C, R minus P. So we have to make a note of two formulas. This is for permutation here. So this is for permutation and this is for combination. So this is for first case. What's the first case? Mandatorily they will occur, must occur case. Yes, please join with me. Restricted case. First case must occur. Here we'll introduce one more alphabet along with N and R. We introduce P, which is this P number of items should occur, must occur. So for permutation, what's the formula? N minus P, P, R minus P. That is instead of NPR, we are considered, so we are removing P. And we'll have this internal arrangement, which is R, P, P. So I can just highlight this term as internal arrangement. Okay. And you can also make a note this. See, we already have this relationship. This R is less than or equal to N, right? Likewise, if you talk about R and P, this P will be less than or equal to R. Okay. So this is about permutation. And yes, combination. Combination is quite simple. Always combination is simple. Simple. Yeah. C, R minus. That's it. So this is for must occur case. Shall I go for the second case? Yeah, second case. Must not occur. Which means very comfortable, leave them. Actually, we have to make 5 persons in the stage. Anyway, principal and correspondent are not going to. So what you're going to do? Only the 3 guests has to be arranged. So we will think it's 5, but 2 persons are not going to come. So ultimately there are only 3 persons. So leave off them. But anyway, we'll have like N, we'll have R, and we'll have P. Now we'll talk about permutation. Yeah, permutation. What happens here? It's N minus P, P and R minus P. What about this term? It will not come because there is nothing called as internal arrangement because already left out. Okay, so this is R minus P. Is it okay? So you'll not have this. Yeah, here combination N minus P, C, R minus P. Simple. So only this one you have to make a move. Okay. Yes, almost all the concepts done. In the next class, we'll be discussing about the problems. So before that, you have to go through the problems and come, and I'll let you know the assignment.